Should see the title slide here. Again, if you see technical difficulties, please alert me, text me, or shout out. Again, I'm just getting used to how to run stuff in a virtual classroom. Tonight we're going to talk about the global context, right? Context is kind of the broader set of facts, the information around the main topic. In our first lecture a couple of weeks ago, we talked about some of the attributes of sustainable architecture, right? Or green architecture refers to the practice of design buildings which create environments that work to minimize the human use of resources. So tonight we're going to try to answer the question of why do we as architects and construction professionals, why do we have to concern ourselves with minimizing the human use of resources? So that's really our topic for tonight. So let me start with a brief video here. It's gonna...
Happy Earth Overshoot Day! Well, there's nothing happy about it really. This year, Earth Overshoot Day falls on August the 1st, the earliest day ever. Never heard of Earth Overshoot Day or the ecological footprint? Our ecological footprint is how much we demand from nature. Currently, humanity is using the equivalent of 1.7 planets. Every year, Global Footprint Network calculates Earth Overshoot Day. It marks the date when humanity's demand on nature exceeds what Earth can regenerate in that year. In 2018, Earth Overshoot Day falls on August the 1st. You can think about this as a bank account. For the first 7 months and 1 day in 2018, we lived on our regular salary. After that, we start tipping into our savings and racking up credit card debt. Seems like there's something wrong with that math. The ecological footprint measures how much land and water area we need to produce the resources we use, things like food, land for settlements, timber, seafood, and to absorb the waste and carbon dioxide we generate. Our biocapacity is the amount of biologically productive areas, such as forests, fishing grounds, crop and grazing areas, that are available to provide the resources we use and to absorb our waste. We can compare footprint and biocapacity to see if we are well balanced or not. Why do we care about humanity's ecological footprint? The costs of ecological overspending are evident every day in the form of deforestation, drought, biodiversity loss, and the buildup of carbon dioxide in the atmosphere. Ecological overspending can also put nations at more economic risk. Without sufficient resources, it is hard to operate an economy, or we have to import more, which has costs as well. Carbon emissions from fossil fuel use are a big part of today's footprint. Today, humanity's carbon footprint makes up 60% of the world's total ecological footprint. Individuals can measure their own ecological footprint with Global Footprint Network's new calculator. Mine is 3.5 global hectares. In fact, you can even calculate the date of your own overshoot day, the day when the world would go into ecological overshoot if everyone on the planet lived like you. If your overshoot day falls before August the 1st, that means your ecological footprint is larger than the world average. You can learn more about sustainability solutions by joining the Earth Overshoot Day #MoveTheDate campaign. Make steps to take actions to move back the date of Earth Overshoot Day and share them and the calculator with your friends and family. If we can move the date of Overshoot Day 5 days per year, we will be living sustainably on our one planet Earth by 2050. Help move the date, calculate your own ecological footprint and overshoot day today. Visit www.overshootday.org.
Okay, hopefully that came through. So again, Why do we as architects and construction professionals need to concern ourselves with the human use of resources? Well, the short answer is that we're using resources at a rate almost twice as fast as the Earth's ability to renew those resources, right? We obviously can't do that forever, right? You can't overspend your bank account forever. You can't draw down your credit card debt forever. That's what we as human beings are doing. Um, in the video there, the gentleman used two terms. One was ecological footprint, so the land and water area needed to produce the resources we use and to absorb the wastes we generate. And biocapacity is the biologically productive areas that are needed to provide the resources we use and absorb our wastes. So we need to make sure we keep these things in balance. Does that make sense?
Yes,
Okay. Pardon?
I
Thanks,
said
Susan. Yeah.
yes.
Great. Well, obviously, we took a bit of a detour this past couple months here with COVID. Earth Overshoot Day got moved back almost 3 weeks, as you see. You might think of that as a good thing. We did, when all our economies got locked down, when people stopped driving, et cetera, et cetera, we saw a market reduction in our use of energy and resources, right? We experienced lockdown. We might think of that as a good thing. Well, so you see that Overshoot Day got moved back 3 weeks in 2020. You see that it's kind of gotten earlier and earlier in the year. In these years that this organization has tracked it, again, we're at 1.6 or 1.7 Earths. The reality, though, is that this sudden contraction of our ecological footprint, this sudden moving back of Earth Overshoot Day is really not a planned or intentional change, right? It's not sustainable, right? We're using less resources. That's a good thing, but lots and lots of people are out of work, right? So lots of people's well-being is being impacted. So we're not achieving both ecological balance and meeting people's goals or people's well-being. So we're not really sustainable. To be really sustainable, we have to achieve this reduction in our footprint by plan or by design rather than having a disaster, right? If we get there by design, hopefully, then we are getting much closer to sustainability. Okay, so we're going to touch on a couple topics here, part of the context of sustainability to help answer the question of why we need to minimize the human use of resources. Again, I'm an engineer by training, so you'll see lots of graphs and numbers up on the screen here. That's the way that I like to see things and the way that I can visualize data. So at the bottom, the numbers in solid here show the projected, the actual human population and its projected growth. So by the end of this century, the 21st century, there might be close to 11 billion human beings on the planet. As of 2019, there were 7.7 billion of us, right? So the bad news is that we continue to grow the human population and its impact on the earth. The good news is that we've been able to turn the rate of growth around, right? You see that the growth rate peaked sometime probably in the early to middle 60s. It's somewhere around what 2% a year, and growth rate has been falling. So every year that means that there are fewer and fewer of us growth-wise, but we still have a large population that we need to have resources to support. If we look at how population is growing in various different countries of the world, and again on my slides here, as I've as I've gone through these year after year, I've kind of added some red text to highlight the key points. So in the developed world, right, we in the United States are in the developed world. Western Europe is the developed world. Canada, Australia, New Zealand, right? Japan, right? Those are all considered the developed world. So in the developed world, growth rates are generally falling. In the developing world, right, in sub-Saharan Africa and Southeast Asia, growth rates are still much higher. And actually, some countries are experiencing a population decline, which has its own set of problems. And Japan is one of those countries. So again, as we move forward, more and more of that growing population will be in the less developed regions of the world, right? Africa especially. But our impact on the Earth is really multi-dimensional, right? I'm showing it there as 3 dimensions. So it's the combination of population growth and economic development that multiplies our impact, right? We have 7 or 8 or 10 billion human beings on the Earth, and many of those human beings aspire to the same same degree of material prosperity that we in the developed world have enjoyed, right? So we not only have a growing human population, we have a growing population looking to have the same prosperity, the same stuff that we in the developed world have enjoyed. You know, that's really where the rub comes in. I saw this study a couple of years ago. It looked pretty interesting. Right, we are to provide, you know, part of our challenge as being sustainable is to provide a good life for all human beings and do so within the limits of the planet. And unfortunately, nobody's figured out how to do this. No country yet has figured out how to meet the needs of its citizens and do it at a sustainable level of resource use. Right? So what are some of those indications of meeting the needs of humans? Would be satisfaction, life expectancy, nutrition, sanitation, education, social support, equity, equality, employment, right? All the things that talk about whether human needs are being met. Right? What are some of the planetary boundaries, right? Some of the aspects of the global footprint, obviously CO2 emissions, and some of these other biophysical indicators are talking about them: access to water, wastes, footprint, material footprint. Putting those 2 things together, we unfortunately have not figured out how to live sustainably. Again, we in the developed world, right, we do a pretty good job of meeting the needs of our citizens, but we do so at the cost of exceeding our global footprint. And on the other hand, the countries down here that are not using resources as dramatically as we are in the developed world, they haven't figured out how to meet the needs of their citizens. So really, we want to figure out how to live up here, right? Meeting the needs of our citizens and doing so in a way that stays within the boundaries of the planet in terms of resource use. Again, I have you all unmuted, so if you have any questions, if anything doesn't make sense, please shout out questions here. We're going to talk a little bit about water usage, right? And again, I'll post these slides, but the reality of the water that we use, that we consume, is not what we use directly, to wash our hands and to flush the toilet and take a shower. Most of that water use is embedded in the food we eat and the energy we consume and the products we buy. I think we got a new water meter on our house, so it's probably 2 years ago now. And so I started tracking, again, being the geeky engineer that I am, I started tracking our water consumption and filling numbers in a spreadsheet. And Francis and we use about 76 gallons of water a day, right? So and that's probably a little under what an average American uses, right? But if I'm using 76 gallons for my direct measured domestic use, there's an awful lot of gallons that's embedded in the food we eat and the products we consume, right? 600 gallons to make a hamburger, et cetera, et cetera. I think the same thing. We talked about plastic water bottles in the first class. I think it takes 6 or 7. If that's a 1 liter bottle, it takes 6 or 7 liters of water to produce that 1 liter of plastic water bottle and deliver it to you. So we really need to be looking at these other aspects, again, our food, our energy, and the products that we use. So again, what are the main things? Yeah, we live on a blue planet, but only a small percentage of the water that's on our blue planet is something that's available for us to use. The vast majority of it is in the oceans and not in a form that we can directly utilize as human beings. In the United States here, again, the 2 largest consumers of water are thermoelectric here, means the generation of electricity, and the second would be irrigation or agriculture, right? Here's public supply, right? This is the water that comes out of the water tap. So again, agriculture and energy production are the 2 largest consumers of water in our country. Some parts of the world have a scarcity of water. Again, we're generally lucky in the Midwest, as we are, as you'll see for a number of slides, that right, we have an adequate supply of water, not an unlimited supply of water, as we'll see shortly, but an adequate supply. But we have many other people in the world who are not so blessed as we are, right? And they may not be blessed for 1 of 2 reasons, right? We may have physical water scarcity, which means there is not physically enough water, or we could also have economic water scarcity. Economic water scarcity means that the governments in that part of the world don't have the wherewithal to deliver water to their citizens, right? They're not wealthy enough countries to have water systems and pipes and water taps and flush toilets like we do, right? So again, in some parts of the United States, southwestern United States, we have physical water scarcity, but we have very few places that have economic scarcity. Sorry, my screen size is shifting around here. See a lot of countries in sub-Saharan Africa that are experiencing economic water scarcity. Since we saw that energy production and food production are our 2 largest users of water, we really need to think of these 3 things together, right? Look at how these 3 things are interrelated, right? We obviously need water to produce food. We don't see this as much in the area surrounding us in the Midwest. Generally speaking, we have adequate rainfall to grow the corn and the soybeans that we grow. But if, as I was driving west over the summer to Denver to visit my family out there. Once I got a little bit past Omaha, Nebraska, then I started to see these irrigation rigs, and the crops were being grown by groundwater that's being pumped out of the ground. And if I got further west, then I would see these irrigation channels and water being used to grow food. We obviously need energy to produce food, right? We need gasoline to power, or diesel to power that giant tractor that's growing the corn or the soybeans. We also probably less, we think about it less, is that we need energy to pump that water out of the ground for irrigation, or to pump that water around for irrigation. Again, these things are related to each other. As we address one problem, we have impacts on other problems. Right, we also mentioned thermoelectric, right? It takes water to produce energy. Either in this case, this is Hoover Dam out near Las Vegas, right? We have a dam here that's producing electricity via hydroelectric power. Or probably a more common sight, especially in this part of the world, is that we have cooling towers where the heat from a coal-fired, or this looks like a coal-fired power plant, that heat is rejected by evaporating water. So that's where that water use for thermoelectric comes from. Again, it also takes energy to distribute water. If you, right near Navy Pier, there's a Jardine water filtration plant, right? That's where we get our water from. If you ever happen to go in there, you'll find that there are some quite substantial pumps that use to pump the water out of the lake and push it all over the city of Chicago and the surrounding suburbs, right? So it's taking energy to distribute that water. Out in the western part of the United States, right? These pipes are actually outside Los Angeles, right? Because that water has to be pumped uphill and over the mountains to get to Los Angeles. So again, if we make changes in any one of these things, it'll have impacts on the other, either positive or negative, right? Ideally, we want to make reductions in one area, and that will be enhanced, multiplied by others. In other words, if we save water, that saves energy. If we change aspects of our diet, that will save water, et cetera, et cetera. Some of these slides are a little out of date. You'll see I struggle to keep some of these slides current with all the things that are going on in the world. But we saw there being physical water scarcity in the southwestern United States. Again, this is a view of Hoover Dam, Lake Mead, and you see that water levels are down significantly in Lake Mead, right? That's because the rainfall in the Colorado River Basin is diminishing with climate change. So there's less water to generate electricity at Hoover Dam, and there's also less water to supply Las Vegas. So again, a geek like me, when I went to Las Vegas one time, instead of going to the tables or pulling the slot machines, we took a little tour of Hoover Dam. And yeah, it was a little weird because you drive around and you see this big lake that has essentially a giant bathtub ring around it. Again, these are some pictures from California. We've seen California being in the news about it being stressed by drought. Again, I think these are pictures from a couple of years ago, but that situation is still the case. Again, we don't imagine people running out of water in our modern world, but we ran across, or almost ran across, a situation. Right, Cape Town is one of the major cities in South Africa. Right, Cape Town, they were projecting that they would get to a water day zero. Right, they would get to a situation where the taps in that city ran dry. Right, imagine what that might be like in the city of Chicago or in Oak Park or wherever you live. Right, you turn on the tap someday and nothing comes out. That would be pretty hard for us to deal with. But they were facing that situation in Cape Town, and I'm actually going to show you a little another video here, another clip. But a similar situation in Chennai, India. Chennai, I think in the southern India, maybe in the state of Tamil Nadu. So hold on a sec. Like, this is what water scarcity looks like.
தண்ணியும் கிடையாது, குழா தண்ணி தான். இதெல்லாம் நாங்க எல்லாத்துக்கும் யூஸ் பண்றோம். எதிர்பார்க்கறதா இருக்குது. தண்ணியே கிடைக்க மாட்டேங்குது. 30 பேருக்கு அப்புறம் ஒருத்தர் பிடிக்க வேண்டியதா இருக்குது. 5 குடம் தண்ணி, தண்ணியும் கிடைக்கல. ரொம்ப கஷ்டப்படுறோம்.
வாட்டர் மேனேஜ்மெண்ட் பொறுத்தவரையில ஒரு முழுமையளவுக்கு வந்து கவர்மெண்ட்டை பொறுத்தவரை, அம்மாவுடைய அரசை பொறுத்தவரை, ஆட்சியை பொறுத்தவரை எவ்வளவு செய்ய முடியுமோ அவ்வளவு செய்யிருக்கு. இப்போ 499 கோடி ரூபாய் இப்போ வந்து அலாட்மெண்ட் பண்ணிட்டு, அதுவும் வந்து இந்த பணி வந்து நீர்நிலைகள் ஆழப்படுத்துறது, பலப்படுத்துதல், இதே போன்று குளக்குட்டைகளை தூர்வார்கள், இது போன்ற எல்லா வகையான மேற்கொள்வதற்கு ஒரு 500 கோடி ரூபாய் கொடுத்துருக்கு.
So again, we are not necessarily dealing with that here in the Midwestern United States, but other human beings in other parts of the world are facing that sort of scarcity. And let me get back to my slide here. Sorry. Oops. So these day zeros in Cape Town and Chennai, they were narrowly averted. But again, this is what humans' use of resources exceeding the Earth's capacity looks like, right? This is what our world is going to begin to look like. So you might say, okay, well, we live in Chicago, we live in the Midwestern United States. We live right by beautiful bodies of fresh water. And are we okay here in Illinois? Well, no, not really. Right? You see the greatest water scarcity or the greatest water stress is in the southwestern United States. but there are also some areas in where we live where we have that same situation. Let's take a look at that. Right? Why is that? Well, the reason is that, yes, we live near these large bodies of water, but the amount of water that we can withdraw from the Great Lakes is limited, right? It's limited by a treaty that was signed between the United States and Canada. We signed a thing called the Great Lakes Compact, signed into law by President Bush 2008, and it bans the diversion of Great Lakes water outside of the basin. So it says you can't take water outside of the Great Lakes basin. So in our case, right, the dividing line between the Great Lakes watershed and the Mississippi River watershed is fairly close to where we all are, right? If those of us in Oak Park, if you go to Scoville Park, there's a little sign there that says, right, here's the Great Lakes watershed and here's the Mississippi watershed. So again, this compact limits how much water can be taken out of the watershed. So again, we in this area, because of the fact that the dividing line between the two watersheds is fairly close to the lake, the amount of water that we can use is also limited. Now, that might be something bad for us, but it's also good because it also prevents other folks from elsewhere in the country from thinking that they can come and divert Great Lakes water, right? At one point, people were talking about building a giant pipeline from the Great Lakes to Arizona to get water to Arizona, right? We can't do that, right? We can't do that because of the Great Lakes Compact. So all in all, a good thing, right? Okay, we're going to shift gears slightly, and we are going to talk about the greenhouse effect, right? So the greenhouse effect, yes, this is a greenhouse. Again, in the fair village of Oak Park where I live, we have a nice, tidy little greenhouse. So, but this is not the greenhouse effect that we're going to talk about. We're going to talk about this greenhouse effect, right? We're going to talk about why the temperatures of the Earth are getting warmer and warmer, right? This is the greenhouse effect, right? This is something that is important to understanding what's going on at the present time. So the greenhouse effect says that, and this is why, right? This is why the plants in this kind of greenhouse stay warm in the wintertime, right? Because the sunlight shining in through the glass warms up the soil and the plants, and that energy is re-rated in the infrared range, and that glass traps that energy from leaving the greenhouse, from being re-radiated, right? The same thing happens in our atmosphere, right? The sun warms the surface of the Earth, and some of that warmth is emitted back into the atmosphere, and the components of our atmosphere keep that heat in the atmosphere, right? When we talk about the current situation, we used to use the term greenhouse effect to talk about warming of the Earth, but now and sometimes we talk about global warming, but the most correct way of referring to that is global climate change. So global climate change 101. 101 is brief introduction. Here are the main facts. Atmospheric CO2 or carbon dioxide levels have increased dramatically due to human activities. Human activities, humans are us. Those activities are the burning of fossil fuels. Due to the greenhouse effect, right, as we put more CO2 in the atmosphere, we inhibit the ability of some of that energy to be re-radiated back out into space. So due to the greenhouse effect, less of that incident solar energy, incident being the solar energy that's coming from the sun and shining on the earth, less of that energy can leave the earth and get re-radiated out to space. So as we have more heat in the atmosphere, what does that mean? That means higher temperatures. Those higher temperatures mean that we are melting glaciers, we are melting land ice, we are also melting sea ice. We'll see what that means in a minute. We're warming the ocean. We're rising sea levels, so sea level is rising. We have altered patterns of rainfall. Some places are getting more rain, some places are getting less rain. And we have more intense storms. I think in your current event reading, you should have seen some of those things. Right, and again, these are things that these are slides that I need to keep updated. So what does climate change look like? These pictures are from the campfire in California last year. But if you look in the newspaper, you would see pictures that look very, very similar to this, right? 2020, when I looked at the newspaper the other day, wildfires across the West Coast, California, Oregon, Washington, have burnt up more than 3 million acres. 3 million acres in California, 1 million in Oregon, right? And we still have many months left in the fire season. Why is it that climate change is causing this, right? There's changing patterns of rainfall, so sustained drought. California's been facing a drought for many, many years, and warmer temperatures. And these are things tied to climate change, tied to us as human beings. We're now building further and further out into areas that were once wilderness. So that's climate change. Right, these pictures are from a couple years ago, Hurricane Harvey in Houston, right? Greater than 50 inches of rainfall, right? Inundated the city, unprecedented. Again, if you look in the paper today, I was looking at the storm track for Hurricane Sally, right? Hurricane Sally is projected to make landfall sometime probably tonight or tomorrow. And they're talking about 10 to 15 inches of rain in Mobile, Alabama, right? That's global climate change. The ocean is warmer, so it has more energy to build up storms. The atmosphere is warmer, so it has a greater ability to hold rainfall. So climate change is having a direct impact, right? And if you looked in the paper a couple weeks ago, we just had Hurricane Laura that just hit between Louisiana and Texas. So how do we know that atmospheric CO2 levels have been increasing? Well, we know it because we have been measuring it. Right? We've been measuring since the late 50s. Scientist by the name of Dr. Keeling has made physical measurements of CO2 levels in the atmosphere in Mauna Loa. This is in Hawaii, right? So this is actual data. And when I just was making these slides up a couple weeks ago, or a week or two ago, we stood at 412 ppm, parts per million CO2 in the atmosphere, right? Doesn't seem like much, but it's a big change over what we have seen in the past, right? You'll see the same curve shape reappear in a couple different spots. Right, I highlighted about 1760, right? This is the start of the Industrial Revolution in Britain. This is when we as human beings started to dramatically increase our use of fossil fuel. What was the Industrial Revolution? This is when we figured out how to take coal, dig it out of the ground, and burn it and create motion with the steam engine, right? So this is when we really started to dramatically increase our use of fossil fuels. And oh, by the way, you see that our production of CO2 in the atmosphere increases as well. Right, so this is what, the last 200 years or so. Let's go back in time, because maybe this recent increase in CO2 levels we have is just an anomaly. Maybe if we look far enough in the past, we'll see something similar. Right, so we go back 8 or 10,000 years ago. What was happening? Right, we as human beings were just figuring out how to grow things. Settled agriculture means that we started to gather in towns and cities and grow things, right? Instead of being hunters and gatherers, we started growing our own food. Mesopotamia, that's the area of Iran and Iraq, right? So this is kind of what human beings have been doing for the last, what, 10 or 12,000 years. And CO2 levels have been fairly steady during that time period. Wow, except for this period right in the last 50 or 60 years when they've increased dramatically. Right? Go back even further again. What, 50 or 70,000 BC, modern humans, Homo sapiens, we walked out of Africa and populated the world. Again, we walked out of Africa with CO2 levels probably somewhere in the 250 or less ppm range, and now we're up in the 400. So what does that mean? So current CO2 levels are higher than any time in at least the last 800,000 years. So what do I think? I think that we as humans are conducting a giant science experiment on ourselves, right? We're operating with an atmosphere that's different than anything we've experienced in recorded human history, right? In our entire history as human beings on the earth, we've never been in this situation. Okay, I actually had to divide my lecture into two pieces because it didn't all fit onto the virtual classroom here. So I'm going to stop sharing this, and I am going to touch on something briefly, and then we'll take a break. I have these assignments. The book report assignment has been up on Blackboard for a couple weeks. I know it's probably seems in the distant future, but the future is now, or the future is coming upon you. So let me just briefly walk through what I'm wanting for you to do. Right, I put this PowerPoint is up on Blackboard as well as all these assignments. So why is it that I want you to read a book, to do a book report? Well, the first and most important thing is that I want you to get into the habit of reading. Right, reading is where I believe you should be getting important information. Again, maybe I'm old-fashioned, maybe I'm an old fogey. To me, getting information from your Twitter feed or Facebook, I mean, that might be how you get information, but I don't think you can get substantive facts, the facts that you need to run your life and make decisions. I'm not sure that you can get that. So you have to read. So I want you to read. I want you to get in the habit of reading. I want you to learn something new. I'm hoping we can figure out how to have each of you run your presentation on the virtual classroom here. That's part of my job here in the coming weeks. This will be a little different than what I've done in past years, right? In past years, I've had students stand up in front of the classroom and practice their public speaking skills, right? We won't get to do that this semester, but we'll try to make it work. So 3 parts. Choose your book. I think post it on Blackboard, and I will take a look and I'll send you an email that says, yep, looks good to me, or I might have a suggestion. Boy, I'm not sure, that might be a difficult book, or I may not recognize it, but I will let you know that you're good to go. If multiple people come and look for the same thing, then it's first come, first serve. So again, I'm not looking for you to write yet another book. I'm looking for just a brief written report. What are the topics in the book? What are the key details? What did you take away? What did you learn? Is there anything that you would do differently in your life or your career by virtue of what you've learned? I will also have you prepare a PowerPoint presentation. Again, I'll have to figure out how to make this all work in the virtual classroom. But again, this is you're sharing with your classmates. Again, what are the key messages? What did you learn? Did this book make an impact on you? Is this something that you would recommend that your classmates find out more about? So again, your book choice, that should be the 21st, right? Next week. So please get your choices into Be My next week. And book reports and presentations are due in early November, right? That seems like a long way off, but it's going to take a while to look around. It's going to take a while to find a book. It's going to take a while to read a book. So give yourself enough time.
Dan,
Yes.
I think on the syllabus, or somewhere on Blackboard, the book choice, I think, is not due until the 28th.
Okay, I will double check.
I think.
You know what? I will double check that while we're on break.
Okay, thanks.
Yeah, sorry. I try to make all these things line up, but you remember when we were doing our campus tour a couple of weeks ago, I pointed into the library and I said, oh, if you look in there, there is a rack of books on architecture and sustainability. Hopefully they haven't moved things around, but you can go in the library at Triton. The library is open. I think it is open generally at normal hours. Right? If you want to show up on campus, you've got to do your little application, your little app. Sorry, my phone reminds me every morning that I have to do that if I want to go to Triton. There is a reference librarian. I actually should have checked whether this woman, Dubravka, is still there. She was the reference librarian who was most familiar with the architectural collection. But again, if you don't find something on the shelf, you can always ask around. The other source that we have is interlibrary loan. Again, when I was at Triton prior to our walkthrough, I did check, and this is back up and running for the most part. Right? I think there are some colleges and universities that aren't participating. But again, if you follow links here, then you can log on to this iShare and you can search for books. I think the login information is your ID number on your Triton ID. And again, you can type in something and search for books and see what's interesting. mean, again, I did this just to try this out a couple years ago. I think I was typing in tiny houses or prefabrication. I ordered up a bunch of books. They all showed up at the library a couple weeks later, a week or two later. I went and checked them out and you know, found the new book. So again, I would, this is certainly one way of going about it. But again, I wanted to give you a heads up so you have a little bit of time to prepare. Any questions?
I have a quick one.
Sure, go ahead, Bryn.
We're already thinking about when I'm gonna get around to getting there.
Yes, I know you take your bike to campus, so it's probably a little bit more of a challenge for you.
You know, it's gonna be practically dry all week, so no rain. Shoot.
Yeah, this might be a good week for bike riding. Last week probably wasn't the best bike riding weather, but hopefully this week is good for you. Yeah, again, I'm trying to give you time to think ahead and plan ahead. Any other questions?
Yeah, I have one.
Sure, go ahead.
Do we have anything else due besides the book report
Um,
and the
you will.
presentations, but like sooner?
Yes, you will see. I think for this class, I had some. Well, in terms of major things, no. In terms of either current events reading or readings in your textbook, yes. So there'll be things like what we had for this class, but again, I think those are things that you can knock out in relatively quickly. But in terms of major activity, this is the major activity for the semester. And while I'm looking at people, Abby, Brian, Bryn, Chloe, Guillermo. Sorry, I'm just looking at who. Hey, Jeffrey, it looks like you must have come after I started my lecture. I'm just trying to count people that I see on the screen here with people that we started with. So it is 8 o'clock. Why don't we take a 10-minute break? Okay, folks, we are back. I hope you are back as well. I think, Susan, you asked a question about when the book choice was due. You are correct. It is due on the 28th, which is 2 weeks from tonight. So my apologies. I will fix that in my materials, so everything is consistent. Any questions on the material that we have covered so far? Okay, again, we are talking about global climate change. Again, you may have heard it referred to as, oops, I guess I recorded the break here, so I'll have to edit that out or figure out how to edit that out. Anyways, you've perhaps heard of this phenomenon referred to as global warming or the greenhouse effect. Again, the correct term is global climate change. So again, global temperatures are rising as a result of all that carbon dioxide in the atmosphere that's coming from the burning of fossil fuels. Right, when I did this a couple of years ago, 2018 was the 4th warmest year on record. 2019 was the 2nd warmest year on record. You see, to date, 2016 has been the hottest. But in the last, in the last 20 years, the Earth has gotten markedly warmer. Let me play a brief. If I can get this thing to play here. I thought that was useful because it shows things visually better than I can on just a static slide. There's a link here on the slide. Again, I will post links for all the material that we've seen or that we will see tonight. So that increase in temperature is not equally distributed around the Earth. If you saw the little globe spinning around there, you saw there were some warm spots and some relatively cooler spots. The temperature change is especially pronounced in the Arctic, right, the northern part of the globe. What do the warmer temperatures in the Arctic means? It means that we are losing sea ice. Sea ice is ice that's floating on the ocean as opposed to land ice, which we'll see in a minute. You may have probably seen pictures of polar bears stranded on ice floes. Their world is being turned upside down, right, because all the sea ice is diminishing. The other thing is that this is an example of a positive feedback, right? In the case of that sea ice melting now, instead of having a white surface that reflects some of that sunlight back into space, we now have blue ocean, which it has a different reflectivity. So this is a case of a positive feedback, right? In this case, it's a bad thing. The impacts are being amplified. We are also, because of rising temperatures, we are also melting glaciers, both in Greenland and Antarctica. And Greenland and Antarctica are land ice. This is ice that's on top of a land mass. When land ice melts, that raises sea levels. So, right, the Arctic is sea ice, right? When the ice cube in your cocktail melts, right, the level of your cocktail doesn't change because that's sea ice. When land ice melts because of global warming, Greenland or Antarctica or glaciers elsewhere around the world, that raises sea levels. So sea levels are rising, right? Why are they rising? They're rising for a couple of reasons. Number one, a lot of that heat that we put into the atmosphere due to increased CO2 is actually being absorbed by the ocean. So the oceans are warming, and we know that when water warms, it expands. So part of the rise in sea level is due to warmer water, and part of it is due to the melting of those land-based glaciers. The other thing we're doing is we are impacting the chemistry of the ocean. We're making the ocean more acidic. Some of that CO2 is being dissolved in the ocean, and the ocean's becoming more acidic. Again, these changes are relatively small, except if you happen to be a sea creature and you've evolved for tens of thousands or millions of years to have a habitat with a fairly tight range of temperature and acidity. In this case, those changes matter. Right? The other thing we saw is altered patterns of rainfall. Right? Some places it's going to rain more, some places it's going to rain less. Right? We know that it's raining less in the western and southwestern parts of the United States. Part of the reason we're having these intense fires in California is that the amount of rainfall has diminished. So all this fuel, all these forests, all these grasslands, that fuel is dry. That fuel is also warmer because the temperatures are hotter. In other parts of the world, rainfall is increasing. But so what does that actually mean to human beings? I found this news clip in the newspaper a couple of years ago. Right? I mean, these are all kind of dry statistics. These are numbers and graphs, but they ultimately have impacts on human beings, right? We in the Midwest, we in the United States may not be feeling these impacts, but other people in the world are now being impacted, right? Our fellow citizens of the United States are now being impacted. The ones that have seen their homes go up in smoke and flames by virtue of all the wildfires in the western United States. This gentleman here is in Bangladesh. Bangladesh is a low-lying country right in South Asia. And if you read the text here, he says, well, you know, I used to have a house and a farm, but now my house and farm have been submerged. And because of that, I'm poor. And what am I going to do? Well, I think I might have to marry off my 13-year-old daughter, right? Because I don't have any other options. I really don't want to marry her off because it's not good for girls, he said glumly, but I'm considering it. He insisted that if it weren't for the rising waters and his resulting impoverishment, he wouldn't think of finding a husband for her. So again, maybe we aren't directly seeing the impacts of global climate change, but other human beings in other parts of the world are. So what does climate change really look like? Right? We have more extreme weather events. Right? We had Hurricane Harvey in Houston. A few years before that, we had Hurricane or Superstorm Sandy in New York City. Right? We flooded lots of subway tunnels. Right? All that warmer ocean water means more energy. So larger storms. Right? This year we're seeing Hurricane Sally's about to make landfall. That's what, maybe the 20th or so named storm in the Atlantic. We see patterns of changes in temperatures and precipitation, and plants and animals don't have the ability to cope with that rapid change in climate, right? As we as humans, if climate isn't to our liking, we at least have the option of getting on our car and someplace else, moving to a different place. Well, if you're a tree or an animal, you don't have that option, so you have to live within the climate that you're used to. Right? We see changes in crop yields. Right? Places are getting drier. That impacts our ability to grow things. We have conflicts over scarce resources. We have mass migration. Right? Human beings are moving from place to place now because of climate change, because of more opportunities elsewhere. Right? Island nations in the South Pacific may only be a couple feet above sea level. So if sea level rises, then your nation is flooded and your home goes away. Right? That's a tough thing. Right? Again, we in the Midwest may not be feeling these impacts yet, but others around the world are now being impacted. Right? What does climate change mean for us, the United States? Well, it means it's going to get warmer. This is a graph of number of days over 100 degrees Fahrenheit. By the middle of the century, we have certainly more of those days. I mean, it's extremely rare that it gets over 100 degrees in Chicago. That'll become much more prevalent. Right? You see parts of the country where it's going to be very common. Right? Phoenix, I was in Phoenix a couple of years ago. It was 120 degrees. That's just hot. By the end of the century, right? Look at how many days we could have, a month's worth of temperatures in Chicago that are over 100 degrees. That's not something we're used to. What does climate change also mean for us, for the United States? We talked about rising sea levels. Well, where are rising sea levels most likely to have impact, right? Obviously not for us in the Midwest. We're 500 some feet above sea level, so sea level has to raise an awful lot to impact us. But if you happen to be in the New York City and New Jersey metropolitan area, you see that there are areas that will be impacted by this I think is a 6-foot rise in sea level. This little widget allows you to play with levels of sea rise and see what areas get inundated. Right, here's the city that's going to be impacted the most, right? Miami Beach. A lot of places that are now fancy condominiums and restaurants may be underwater by the end of the century. What does sea level rise mean for us? Again, this is New Orleans, right? As far as I'm concerned, an improbable place to have a city, right? Largely below sea level. So obviously, sea level rise is going to have a tremendous impact on the city of New Orleans. So, by the end of the century, maybe you won't have Mardi Gras anymore, right? You won't be able to toss beads around in a parade because the city is underwater. So let's look at things politically here. Right? World policymakers have set a goal that they want to limit warming to 2 degrees C. Remember, C is Celsius. F is Fahrenheit. We normally, in the United States, we reckon our temperatures in degrees F or Fahrenheit. It was what, 70, it was high, mid 70s today Fahrenheit. A lot of the stuff in climate change is done in Celsius temperatures. Yeah, the scientists are telling us that if we can stay under 2 degrees Celsius, then we can avoid some of these impacts, although we're starting to see some of those impacts already. And scientists have also said, well, if we're going to stay under that 2 degrees Celsius threshold, then there's only so much more carbon we can put into the air. So we'll see what that means. Well, it's a challenge again, because as we saw earlier, populations are growing, rising incomes means carbon emissions are continuing to rise, right? We have to turn this around. I won't watch this link here. did this a couple of years ago, but this particular one is a scientist who is extremely dry. So so a carbon budget is the total amount of carbon that we can put into the atmosphere and still stay within our 2 degrees Celsius budget, right? But we've spent half of that budget already. And we have lots of countries where carbon emissions are continuing to grow. Again, China is now the largest emitter of CO2 on a total country basis. We, as the United States, our per capita or per person carbon emissions are still much, much higher than the rest of the world, right? We're twice the EU, the European Union, 3 times the world average. Right? You see India and China kind of creeping up, but they have a long way to go, right? A long way to go to us in the United States with our suburbs and our cars and our big houses and everything that we have, everything that the rest of the world aspires to have. Again, the science tells us that if we're going to stay within this carbon budget, if we're going to stay within the 2 degrees Celsius, then we have to basically turn around the battleship, right? Instead of having carbon emissions that are increasing, we need to turn around and start having them decrease dramatically, right? 80% by 2050 is probably a good way of thinking about it, right? We have to reduce in this country, we have to reduce our carbon emissions by 80% in 2050. That's 30 years. That's not a lot of time. This is where it really gets challenging, right? Because staying within the carbon budget means that somewhere between 2/3 and 3/4 of the proven reserves, I'll explain that in a minute, of fossil fuels have to stay in the ground, right? Proven reserve means that we've already established that oil or that natural gas or that coal is there. But that stuff has to stay in the ground, right? That's going to be a tremendous challenge. So certainly if you listen to the scientists, they can tell you that the Earth is getting warmer, right? We have data to support that. We have data that shows what the CO2 levels are. And there's consensus that human beings, that's us, are the cause of that. However, there still continues to be a lot of doubt in the minds of the general public, a lot of disinformation out there, right? There's probably, you know, if you go to Facebook tonight when you get home or when you're done with this lecture, I'm sure you can find places that will try to deny the science of global climate change, right? There's probably our president, our leader of our country is out in California today speaking, and he's probably going to deny climate change, even though he's in the midst of, you know, the worst fire season that there's ever been in California. We'll see where some of that doubt comes from in a minute. Right? Politicians have gotten together. They are trying to do things to address some of these issues. Right? They've set the goal of 2 degrees Celsius, and they said, well, if we really want to limit these impacts, we should limit temperature rise to 1 degree Celsius. Right? Again, this gets a little confusing, but bear with me here. So again, this actually Paris happened in, I should put the date here. There we are, 2015, right? This is when the previous President Obama kind of brokered a deal between the United States and the Chinese to break the deadlock and get this agreement where countries agree that they're going to start to pay attention to this stuff. Well, what happened when we elected our current president? He said, well, I don't believe in climate. I don't believe this stuff. We're going to pull the United States out of the Paris Accord. And you see we're joining some very august company, Nicaragua, Syria, just a few other countries have said that they're not going to be part of this agreement. right? A lot of other world leaders have said, you know, we're going to stand by our commitments. A lot of states and municipalities have said, we're going to continue to support this stuff. This was, I think, from my lecture last year or 2 years ago. You know, the science is telling us that, hey, this 2 degrees Celsius target may not be enough. It may not be aggressive enough. Right? If we really want to avoid all the things that we're seeing, if we want to avoid the Hurricane Sally and the wildfires in California, we have to do more. Unfortunately, we're, you know, making that degree of change requires transforming the world economy at a speed and scale that has no documented historic precedent, right? We don't, you know, we have to make these dramatic changes, but we don't really know how to do it yet, right? These are the challenges that we face as construction professionals. Right? Last year, the world leaders got together. This seems like old news now because, you know, COVID has kind of overtaken lots of things. But last year, about this time, right, world leaders got together, and there were a lot of talk, and unfortunately, not much action. You may have been paying attention to this young Swedish woman, Greta Thunberg, who you know, essentially went to this meeting and called BS, right? Say, you guys, all you politicians are talking, but, you know, myself and all the other young people in the world don't believe you're taking action fast enough to protect our future. Again, I think I sent students last year on to participate in a youth climate strike as an extra credit event. Obviously, we're not going to be able to do that this year, but the politicians were talking, and youth, right, people your age are saying, hey, you guys aren't making changes fast enough. Unfortunately, this whole process has kind of gotten derailed by COVID. Right? We saw that COVID has made an impact in terms of reducing our fossil fuel use and our carbon emissions, but you know, that's likely to change again once everything recovers. But the next meeting of these world leaders got postponed, and we don't really know what will happen when COVID is behind us. We will be able to get back to focusing on climate change. I don't know. You know, we're going to have to, but right now we've got this other big thing that we're dealing with, right? We got the elephant in the room that we got to deal with. Right? So we've set these goals, we're trying to do things, but across the board we are not moving fast enough. Right? We've set goals, we made pledges, countries have, but in almost every case, virtually every case, our goals aren't aggressive enough. Right? The United States pledges in Paris are not aggressive enough. Right? China is not aggressive enough. Okay, I'm going to try to wrap things up here as we're getting to the end of our appointed time. Right? This may feel like something that's complex. Right? It may be feeling like it's something that takes place kind of way above your head, and you really have nothing to do with it. Well, I would disagree, right? I think that you have a role to play. Right? You certainly have the decisions that you make as an individual, what you say, how you advocate to your friends and family, whether you choose to be active in the political process. Again, as we're coming up on an election here, I'll start to drumbeat a little bit more about making sure that you get out and vote and participate. And certainly this will impact your career decisions. So again, I believe that you need to be educated about these issues to be a responsible professional, right? Because you're in a business where you can make an impact one way or another. right? Our industry, our businesses are changing, and we want you to be apprised of what's going on out there. Okay, we're going to watch a short little video here, right there. There still seems to be a lot of doubts in the minds of the general public, right? We have lots of politicians, right? Our president saying, well, I don't believe in this stuff. And let's see if we can figure out why that might be. So hold on a sec while I switch gears.
In the 50s, with the wave of public concern about smoking causing cancer, the tobacco companies developed a very sophisticated, probably the most sophisticated effort to confuse the public about science, to confuse scientists about science. And now we've seen a lot of the same people, in fact, have gone over to becoming climate deniers, using exactly the same kinds of strategies.
I didn't think that we'd have a chance of getting, anyone to go to the theater to go see a film about climate change, because Al Gore's already made a film about climate change.
If you look at the 10 hottest years ever measured, they've all occurred in the last 14 years. And the hottest of all was 2005.
And the one thing we've learned is when you explain science to people, it hardens those who don't believe in the science. So it became a film about doubters and how people are able to stop us from believing in convenient science.
In March 2015, director Robert Kenner will attempt what no one else has successfully done since An Inconvenient Truth: debut a successful documentary about climate change.
The tobacco companies knew nicotine was an addictive drug, yet they told Congress,
I believe nicotine is not addictive.
You see the same small group of people that the tobacco industry used working on all kinds of other issues.
Dioxins, pesticides, chemicals in general. I mean, there's no evidence that these are harming us.
And tobacco is a great metaphor because we know those are lies.
I believe nicotine is not addictive.
I believe nicotine is not addictive. I believe nicotine is not addictive. I believe that nicotine is not addictive.
I believe that nicotine is not addictive.
And and when we start to see a lot of those people are the same people, and a lot of the arguments are the same arguments, it makes it a little easier to say, hey, maybe we're being lied to about other things, including energy.
The movie Merchants of Doubt is based on the book by Naomi Oreskes and Eric Conway.
A key part of the strategy from the very beginning is to undermine the idea of scientific consensus. And one of the things they discovered in their own market research was that if you can persuade people that there's no scientific consensus, then people will think that it would be premature to act. So it's a very, very powerful strategy that we know works. And this is why you hear them saying as a kind of mantra, there's no consensus, the science isn't settled, we have experts who don't agree, there's still a lot of uncertainty, there's considerable uncertainty. You hear this phrase, considerable uncertainty, repeated over and over again.
Science historian Naomi Oreskes authored a high-profile paper detailing the overwhelming scientific consensus on human-caused climate change.
So the paper essentially just says that if you look at what scientific experts have to say on the subject of whether or not climate change is underway and whether it's mostly caused by human activities, the scientific community is clear the answer to that question is yes. And so the paper was simply just saying that. That's it. That was the whole thing, nothing more. Yes, this is what scientists have to say.
What was the response to the paper after it came out?
Well, that's when I started getting attacked. And that was when life sort of changed. It was a bit like, going through the looking glass. And one of my colleagues at Scripps, at the Scripps Institution of Oceanography, said to me, you should talk to Ben Santer. Something sort of similar happened to him.
Ben Santer, a senior atmospheric scientist at Livermore National Labs, was a key author of the Intergovernmental Panel on Climate Change's report in 1995. It was Santer who crafted the carefully worded key passage in the document, announcing for the first time that the balance of scientific evidence suggests a discernible human influence on global climate.
So my life changed. Lots of people didn't like that balance of evidence statement, and no personal animus, but I was the carrier of that message. So you take down the message by taking down the messenger.
Ben told me what had happened to him, and then the pieces began to come together because one of the people who had attacked Ben Santer was Fred Singer, and he was one of the people who was attacking me.
The science around secondhand smoke hyped, the science around the ozone layer hyped, going back 10, 15, 20 years.
I'm happy to discuss all of these, since I've been deeply involved in these topics that you mentioned. Let me start with secondhand smoke.
When I was in graduate school, I worked on stratospheric ozone depletion. And Fred would call me when I was in grad school and talk to me about how he didn't think humans were depleting ozone. And before that, he had real questions about whether humans were causing acid rain. He really criticized the work that connected secondhand smoke to health impacts. And now he doesn't think global warming is an issue.
So in 1995, you characterized secondhand smoke as a myth. You guys put out a press release on environmental myths in 1995. Documents in the Tobacco Legacy Library they got from all of the lawsuits over the tobacco companies, where a lot of this stuff has come out. And they say in there that they're extremely happy with your performance on this. This is from Brown and Williamson, how they were arranging for media interviews for you, and you're doing, and so you did a big media, when you released this press release about this, you did this big media study. What are your views?
I'm actually going to stop this here because it goes on in the same vein, but in essence, we have vested interests who are interested in the status quo, right? Status quo means we don't want things to change. And one of the ways that these folks have realized that we can prevent change from happening is to manufacture doubt, right? We have, to say here, vested interests have manipulated public opinion and the scientific process to create doubt and delay action. So delaying action serves the status quo. That was the point that I was trying to make. And we are going to go a couple minutes over if that's okay. So I know I'm scheduled to end at 8:50, but we will go over by a few minutes here. All right, so I asked the question again that these folks are saying, well, are human beings really the cause of global climate change, right? The way that I like to point it out is by laying these two things side by side, right? We have this run up in CO2 emissions. We saw this slide earlier in the presentation, and it matches almost exactly with the run up in our use as human beings of fossil fuels, right? Before, again, 1800, the Industrial Revolution started just before that. We hardly used any fossil fuels. Now we use lots and lots of them, and that correlates to rising CO2 levels, and it correlates to temperature increases. Again, we're here. We've increased global temperatures about 1 degree Celsius on average over the pre-industrial level. We're trying to keep it to 1.5, and we have a long way to go. So let me close with one other video here to kind of think about, are we responsible, right? Climate change has been created largely by the actions of the rich countries of the global north, right? Global north is the developed world. These impacts are largely being felt by the poor in the global south. What responsibility do we have to our fellow human beings? I'm going to ask that question. I don't know the answer. It's something you need to think about. But let me play this next. See if I can get it to work correctly.
It's almost nightfall. Every evening, starving kids go out to get dinner. Climate change has devastated this place. Now there's only one food in sight: cactus. For the children, wild and prickly cactus fruit. Basically, no nutrition. When there's no fruit, they turn to the raw cactus itself. And for the most desperate, chalky ash mixed with water. So where does our next president stand on climate change?
I'm not a big believer in man-made climate change. There could be some impact, but I don't believe it's devastating.
It'll get cooler, it'll get warmer. It's called weather. We're going to cancel the Paris Climate Agreement.
Nobody really knows. Look, I'm somebody that gets it. And nobody really knows. It's not something that's so hard and fast.
I'm Nicholas Kristof in southern Madagascar. President-elect Trump may be in denial about climate change, so I came to see its impact for myself. I've seen hunger all around the world. In some countries, it's because of government corruption. In others, warlords. But here, where it hasn't rained properly in years, the ultimate culprit is climate change. And the West's myopia and passivity about climate are destroying lives across a belt of drought-afflicted southern Africa. A generation ago, this land was lush. Crops, flowers, forests. Now, due to a combination of El Nino and climate change, it's a desert wasteland. This drought in 7 countries hasn't received much attention. Comment ça va? But according to the UN, it's left 1.3 million children malnourished. Severely acutely malnourished by a huge margin. Severely acutely malnourished. Severe acute malnutrition. You see that his arms are like sticks. So what does climate change look like? Major rivers have vanished into puddles. The few wells have dirty water. And the cows, representing the wealth of villagers, their bank accounts for emergencies, are being sold off because they too are starving. For people like Hondrana, there's no debate. Do you believe the climate here is changing? Hondrana has 6 grandchildren. All of them are malnourished. None has ever had a bath. She's 76 and says this drought is unprecedented. Here's the paradox of climate change. It's mainly caused by affluent people, people like us. And those who suffer the most are the poor and vulnerable. Have you ever heard the name Donald Trump? I believe actually you know more than he does about some things because you understand that climate change is happening. Hondrana is one of the lucky ones. In another village, I met Fokandraza and his brother, Buriavi. A year ago, their parents left to find food and jobs. Call them climate orphans. Have you eaten today? Have you drunk water today? They now live with their aunt, Fideline, but she can hardly afford to feed her own kids. With severe acute malnutrition, these boys are at risk of dying. Voriavi can't stay awake during our interview. But I don't blame the aunt. The situation is my fault than hers. Slowly, the social fabric is being pulled apart. There are millions of kids just like Volkan Raza and Voriavi. Their trauma runs deep. It'll carry over and impede growth for generations to come. In most schools, kids are dropping out to scrounge for food. But before I left, I stumbled upon a bit of hope. This small school. Enrollment has soared by more than 50% in 1 year. But why are kids going to school? To eat. The World Food Program offers free meals. I've seen these school feeding programs all over the world. And at 25 cents per day per child, they fight starvation and keep kids in school. But it's a temporary fix. Real systemic change means investing in climate and putting a price on carbon. Let's not forget, these problems are caused by your car and mine. Donald Trump can pretend that climate change is still up for debate. But as long as we defer action, kids in places like this will continue to starve and die.
Okay, I didn't mean to be, well, actually, I did mean to be a little bit melodramatic there, but I wanted you to think about that, think about the vested interests in our country that are preventing action. Sorry, let me get to the last slide here. And think about what role that we might play. Are we responsible? Again, the impacts being felt by those children in Madagascar and Southern Africa are caused by the actions of us folks in the developed world, right? Do we have a responsibility? Do we as human beings have a responsibility to our fellow human beings to make changes? So that's what I'll leave you with. And any questions? Hopefully there's some of you still here.
No, thank you.
Okay, again, I will post this material on Blackboard, the links, the PDF. I'll have to go back and edit down the video if you want to watch it again. And then, again, my goal here was to set the context, right? To give you some reason to think about why it is that we have to minimize the human use of resources. We have to minimize the human use of resources because our resource use is impacting the rest of the world. We have to do something different. So we're going to start to talk about some ways that we can minimize resource use. But again, I wanted to give you a little bit of context to understand the driving force as to why that's such an imperative. So Any questions? Okay, well, I will, again, I will post these materials. I probably have, not probably, I will post another current events reading. I read the newspaper every day. I save and clip things, so there's way more articles that I've collected than we will ever have a chance to look at. So, but I'll find something interesting for you to read, and that was hopefully thought-provoking. And I will see you next week. Again, if you have any questions, send me an email or send me a text. Keep up on Blackboard, and we'll see you next week. Thanks, everyone.
Thank you.
Oh, you're very welcome.